All right, good morning, everyone. Today is classwork 16, part of week 6. This is the second assignment for the week, so make sure you've done everything else before 16, before starting classwork 16, because all these lessons build on each other. Our objective today is students will be able to compute values of future investments with continuously compounding interest rates. So in the last lesson, 15, we talked about compound interest, right? But now we're going to talk about continuous compound interest, okay? So before, we had a compounding period, right? Now we are we're making the assumption, or we're being told that the compounding period is continuous. So what that means is that our interest is compounding like the most number of times possible within a year so that we can maximize like the return or get the most money out of our savings, right? So what happens then is we get this value E, which is called Euler's number. And E is like pi in that it always is the same value. Pi is always 3.14. E is always 2.71. And it's also an irrational number. So just like pi goes on forever and ever and ever, E it does as well. So you can Google that if you want to know more about E. But for now, what you need to know is that this value is going to represent the maximum value that you could get on a savings account, or the maximum number of times your interest can be compounded in order to get this continuously compounding interest formula. Okay, now everything else is going to be the same, so we know P is always the initial value. R is the rate as a decimal. And again, T is going to be time in years only. Okay, so when we do compound interest, time is always in years. When we do continuous compound interest, time is only in years. All right, so let's do a couple examples. What we're going to do first is compare the three formulas that we already have, okay? And then we'll do an example with just continuous compound interest. So for our first example, number 1, it says, a youth group has a yard sale to raise money for charity. The group earns $800 but decides to put the money in the bank for a while. Option 1, they can get a 3% interest rate compounded yearly. How much money would they have in the bank after 1 year? Okay, so we're talking about compounded yearly and how much money is in the bank after 1 year. So we know, since these two things have the same units, we could use our original formula, F equals P times 1 plus R to the T. Now, you might see compounded and think, okay, we can use our formula from lesson 15, the compound interest formula, P times 1 plus R over N to the N times T. And you would be correct. You could use either of these formulas here, because what we have here, when we're compounded yearly and we're looking for T after 1 year, we can use this formula. Or if we think about N, which is the number of times the compounding period fits into 1 year, since our compounding period is yearly, how many times does a year go into a year? 1, right? So then we would end up substituting a 1 in wherever we saw an N value, right? And if we put a 1 here, what's R divided by 1? R. If we put a 1 here, what's 1 times T? T, right? So this formula actually is going to be the same here if it's just compounded yearly, okay? So I'm going to go ahead and start with this, right? So we know that our P value is 800. The rate is going to be 3%. And I think that's all we need for this formula. That's our easiest formula. So F equals 800 times 1 plus, and if it's 3%, that's 0.03, because I would divide I would divide 3 by 100, right, to get 0.03, all to the t. And if my t is 1 year, and my interest rate is yearly, so my units match up, which is good, then I can say f equals 800 times 1 plus, we'll do 1.03. We can add 1 plus 0.03 is 1.03 to the 1 year. Okay, so then we get f equals, and 1.03 to the 1 is just 1.03, so 800 times 1.03. Now that I can't do without a calculator, so I'm going to go to my calculator and say, okay, what is 800 times 1.03? 800 times 1.03 is $824 would be my final answer here if we're using compound interest by yearly, or which is really our percent rate of change formula. Okay, so that's my first answer for the first option. Now let's look at option number 2. They can get a 3% interest rate compounded monthly. How much money would they have in the bank after 1 year? Okay, so we're compounding a little bit more often. So what do you think should happen with this value? Should it be more or less? So let's find out. So again, we've got 3% as my R value. And we're going to use the same P from up here. And now since we have compounded monthly, we are definitely using my compound interest formula from lesson 15. Okay, so if my formula originally is F equals P times 1 plus R over N to the N times T, I need to figure out my N value. I know my P is 800, I know my R is 0.03, but what's my N? So I see this says compounded monthly, so that would be the same as compounded every 1 month, okay? So my compounding period is 1 month. So if my compounding period is 1 month, then I think, okay, N is going to be 12 months divided by 1 month, or how many times is 1 month in a year, which should be 12, right? We get 12 months in a year. Okay, so then I have F equals 800 times 1 plus 0.03 over 12 to the 12 times, and my T value is going to be 1 year again. So 12 times 1. Okay, so I've got 800 times, I'm going to go to my calculator, and I'm going to do 0.03 divided by 12. Okay, and I get 0.0025. So I'm going to add that to 1. I'm kind of skipping a step. I'm not writing it down, but it's best if you write down everything you can. Everything you have room for. Hopefully you have paper. And then 12 times 1. If you don't have paper, just let me know and I'll drop some off at your house. Okay? So now I'm going to do 1.0025 to the 12th power because we do exponents before multiplication. So I'm using my x to the y button to the 12th. And then I have 800 times 1.03, basically, but 304, which will be, multiply this by 800, and I will get $824.33, right? So this is nice, right? So we've got, compared to option 1, we've got 33 more cents in a year if we're compounding monthly instead of just every year. Okay? Let's talk about option 3. We get a 3% interest rate compounded continuously. How much money would they have in the bank after 1 year? Okay. So now this is where we're going to use our new formula. So the compounded continuously formula is PERT, P times e to the RT, and we know my P value is 800. We know E is always just E, my R is 0.03, and my T is 1, right? Okay, for 1 year. So what we can do is now F equals 800 e to the 0.03 times 1 is 0.03. Now, this is going to be a little different on your calculator. If you have a graphing calculator or a calculator that's not on your phone, you would press E first and then the exponent. But on the iPhone, it's like this. We have this E to the X button, okay? So right next to the X to the Y button, there's the E to the X button. So what I actually have to do in the iPhone calculator is I need to first put in my exponent. So I'm going to say 0.03. I put in the exponent first. So I have e to the 0.03. And then I hit the e to the x button. And that's how I'm going to get my value. Okay? You could do, so you'll see I get 1.03045. You could also do, we know e is 2.71. You could put in that and then say, oops, that's not the button. 2.71 and then x to the y to the 0.03. But you'll see it doesn't give us quite as exact of an answer. So what I want you to do is to actually use the e value, right? Because it's the same thing with pi, right? We need to have all of those, oops, let me see, all the decimals, right? So really, e is 2.71828182845945. Okay? So you're doing that to the 0.03, and you'll get 1.03045, which is what we want. Okay? So now I have F equals 800 times 1.03045, etc. And I'm going to multiply this without clearing it in my calculator so I get the most exact answer. Okay? And I got $824.36. Okay? So that's how we do PERT, and we're going to do another example in a second. But just to end this example out of comparison, which option should the youth group choose to make the most money? So remember, with our regular percent rate of change for 1 year, we got $824. When we're compounding monthly, we're $824.33. Then when we're compounding continuously, we have $824.36. So in order to make the most money, we're definitely going to do option 3, compound continuously. Option 3. Okay, so the point here is that compounding continuously is gonna make you more interest than compounding monthly, right? You can't get compounding any more often than continuously. Okay, so let's do one more example, and then you'll have a couple problems in the Google form to do on your own. All right? So example 2. Marcel deposits $3,000 into a retirement account that has a 6% interest rate that is compounded continuously. Write a formula to model how much money Marcel will have after each year. How much money will he have in 20 years? Okay, so I like to underline what we're being asked to do first. So we're being asked to write a formula and then determine how much money will be in the account in 20 years. Okay? So then we also know this is compounded continuously. So what formula are we going to use? If you said PERT, that is correct. P e to the RT. Okay? So we need to figure out my P value, my R value, my T value, right? So P is initial value. We're starting with $3,000. And then my 6%, that's going to be my R, right? My rate. So, an R, as we've been doing for the past 3 lessons, we're always dividing by 100 in order to get a decimal. Okay? So, when I substitute these values into my formula, I get $3,000 times e to the 0.06 t. Okay, and there's not supposed to be this mark here. I just messed up. So my formula, let me just write it again, just so it looks good. F equals 3,000 e to the 0.06 times t. Okay, so that's my formula. Part 1 is done. Now, they're saying how much money will we have in 20 years? Okay, so that means if t equals 20, because when we use compound interest or continuously compounding interest, my t value is always in years. 20 years, we're good to go. So I'm going to substitute 20 in for t. So I'll have F equals 3,000 e to the 0.06 times 20. I'm going to head over to my handy dandy calculator, and we'll do 0.06 times 20. Okay, so then I have 1.2, so that's 3,000 e to the 1.2. And remember, this is a little different. Whenever I have an e to the power, I'm going to put the power in first and then press the e to the x button. Okay, so I got F equals 3,000 times 3.32 approximately. But I'm going to keep this in my calculator so I can say times 3,000 and get the most accurate answer. Okay, so if you're a couple decimal places off on the Google form, that's fine. I will fix that, or I will fix your score. But if you're being most exact, you have 9,960.35. Like we did in the last lesson, 3,000 times 3.32. If we did that, we would just get 9,960, and we would be missing the cents, right? So this is our most precise answer. But if you aren't able to put everything in your calculator, I'll still mark your answer as correct. Okay? So if you have any questions, feel free to watch the video again or text me or come to my office hours. Okay? Good luck. I will talk to you all later.